This is First Coast Math Clinic with Lesson 3, Solving Multiplication and Division Inequalities with Positive Coefficients from Unit 3, Inequalities, from our Pre-Algebra and Algebra curriculum. So the goal in this video is to solve and check multiplication and division inequalities with positive coefficients. So our focus is going to be multiplication and division inequalities, and we're going to talk specifically about with positive coefficients. We'll talk about that in a second, but just a quick review of inequalities. So we know our inequalities are mathematical statements with greater than, less than, greater than or equal to, and less than or equal to, or less than or equal to. So let's take a look at the example 2x is greater than 10. So our coefficient in this example is that 2, and we're only going to be dealing with positive coefficients. So we won't have something like a negative 2x. We're going to deal with like how to deal with a negative coefficient in the next video, but we're just going to deal with positive coefficients in this video. So I've got 2x is greater than 10. Well, I want to get that x by itself. So how do we get the x by itself? We want to use our inverse operation. So our inverse operation of multiplying 2 and x is division. So let's divide by 2, divide by 2. 2 divided by 2 is 1. I don't need to write the 1 in. So I get x is greater than 5. So this is my solution set. X is all values greater than 5. So let's draw out our graph. We want an open circle at 5. Larger values to the right, smaller values to the left. So we get 6, 7 to the right, 4, 3 to the left. X is greater. So let's shade to the right. Now our check. Well, let's pick a value in that solution set. So I want a value greater than 5. So let's maybe choose 6, right? Because that 6 is in our solution set. So in our original inequality, 2x is greater than 10. I'm going to replace x with 6. So I'll get 2 times 6 is greater than 10, and then 12 is greater than 10, which is a true statement. Number 2, y divided by 5 is less than or equal to 2. I want to undo this division, so how do I undo dividing by 5? I multiply by 5, so I'm going to multiply the left side and the right side by 5. Since the left side has a fraction, I'm just going to put that 5 over 1 to make my multiplication a little bit easier. 5 times y is 5y. 1 times 5 is 5. Now I'm dividing 5 and 5. 5 divided by 5 is 1. So I don't need to write the 1s, and I can just write out y. Greater than or equal to 2 times 5 is 10. So y is less than or equal to 10. So that's our solution. Let's draw our graph. Now I want a closed circle because it's less than or equal to. Smaller values to the left, larger values to the right. So 11, 12, 13 to the left, 9, 8, 7, 6 to the left. Y is less than, well, our less than values, if y is less than, our variable is less than our number, we're going to shade to the left. Now, if you want a review of how to graph an inequality, you could check out the link for the video that's going to appear right now. I made a video on graphing inequalities a little while ago, so that link should be appearing. So this graph represents our inequality. Y is less than or equal to 10. So now let's check this. So let's pick a value from the solution set. We could pick, since we shaded in that 10, we could pick 10 as part of our solution, right? So in our inequality, y over 5 is less than or equal to 2. We could replace y with 10. So I'll have 10 over 5 is less than or equal to 2. 10 divided by 5 is 2, and I get 2 is less than or equal to 2. which is true. Let's pick another value, right? If I continue this, we know we're going to have 5 in the solution set as well. So I could pick 5 as well, and then do 5 over 5 is less than or equal to 2. 5 divided by 5 is 1. 1 is less than or equal to 2, which is true as well. Number 3, negative 4 is less than or equal to y over 3. So again, we're dividing y by 3, so let's undo the division and multiply by 3. I'm going to put that 3 over 1. Multiply by 3, all right? So multiplying straight across, y times 3 is 3y. 3 times 1 is 3. 3 times negative 4 is negative 12. 3 divided by 3 gives me 1 and 1, right? But I'm dividing and multiplying by 1, so I don't need to write the 1 in. So I'll just write y, and then negative 12. So negative 12 is greater than or equal to y, or y is less than or equal to negative 12. So our inequality is opening towards the negative 12, so that's our greater value. All right, let's graph this. Negative 12, and I want a closed circle at negative 12. Greater values to the right, lesser values to the left. So again, think of our number line, right? This is negative 11, negative 10, negative 9, negative 8, negative 13, negative 14, negative 15. Okay, now if my variable, again, is less than my number, I'm going to be shading to the left. All right, so let's shade to our left. So this is our graph. Now for our check, we want to substitute a value into our inequalities for negative 4 is greater than or equal to y over 3. Now think about this. Whatever value we substitute in for y, we're going to be dividing by 3. So we want to pick some decent values, right, from this solution set. Well, negative 14 is in that solution set, but I don't think it would be a good choice to choose negative 14 as part of our solution set, because if I put negative 14 in for y, then I have to divide negative 14 by 3. I'm gonna get a messy decimal. It's not going to work out as clean as I want it to be. So let's pick some values that are easily divisible by my denominator. All right, so what are some values in the solution set that are divisible by 3? Well, I noticed that we've got negative 12 here, right, and we've got negative 15. All right, and if we were to kind of continue this line, right, what else would we have? We'd have negative 16, negative 17, negative 18, right? So kind of squeezing that in a little bit, but we'd have negative 18 here as well that we could use. And then if we continue that, negative 21, negative 24, negative 27, so all the values that are divisible by 3. So let's do 2 of these. So we'll do negative 12, and then we'll do negative 15. So we'll do 2 checks. So negative 4 greater than or equal to negative 12 over 3. Negative 4 greater than or equal to negative 12 divided by 3 is negative 4. So this is going to be true. Then if we check negative 15, negative 4 greater than or equal to negative 15 over 3. Negative 4 greater than or equal to negative 5. So you can remember on our number line, the value closest to 0 is going to be our larger value. So negative 4 is closer to 0 than negative 5, so that's going to be our larger value. Okay.